Okay, Stickman is pushing a 10.2 kilogram box with a force of 40 newtons, and it's directed downward from the horizontal on an angle of 30 degrees. As you can see, the Stickman is not using his head. Anyways, you can actually see through the head to the other side of the blackboard, so he might not be all that bright. Okay, this is 40 newtons here. 20 newtons are going to be directed into the ground, and so that's actually going to make this job a little bit harder, because what I didn't mention at the start was that the kinetic coefficient of friction was 0.1. To find the force of friction, you multiply the normal force by the coefficient of friction. Okay, so we have a component of the force going into the ground, and then 40 times the cosine of 30. Oh, have to turn it on. $34.6. And so 34.6 newtons of force is actually going to accelerate this box parallel to the surface. So let's define our directions. To the right is going to be positive x, upwards is going to be positive y, gravity is going to be downwards, and just like always, gravity is going to be negative. Anyway, so the applied force in the x direction is 34.6 newtons. The applied force in the y direction is 20 newtons. The force of gravity in the x direction is 0. Oh, this should be a negative 20. And the force of gravity, 10.2 times negative 9.8 is negative 100 newtons. So the force of friction in the x direction, the y direction winds up being being the normal force. And so 20 newtons here is going to add to 100 newtons of force downward. And so altogether we have, I have to put in the normal force, don't I? I'll maybe make this later. That's okay. We'll do this now. So the normal force has to be positive 120 newtons. Force of friction is always going to act opposite the direction of motion, and the force of friction is always proportional to the normal force, and it's equal to the normal force times the coefficient of friction. So the force of friction is going to be negative 12 newtons. Normal force in the x direction, of course, is 0. The net force in the x direction is going to be 22.6 newtons. And so now we are ready to go with our sum of forces in the x direction is equal to the mass times the acceleration in the x direction. And of course we turn it into an acceleration problem. I probably didn't say that. 22.6 newtons divided by our magically 10.2 kilograms. And probably, I'm still on the screen. 22.6 divided by 10.2 is 2.2. All right. He's not going to be able to keep that up for very long. 2.2 meters per second squared. Hope you can see that. And so this is a problem that involves friction. Friction is proportional to the normal force. You can calculate friction by multiplying the coefficient of friction by the normal force. And otherwise, this winds up just being an F equals ma problem.